Okay. So now it's recording. Welcome to today's session. We'll be going through the memo for practical 4. The one that you guys were being marked on yesterday, right? Today is Saturday, no? Yeah. So let's start. So you have a practical that you're supposed to solve using a while loop, a do while loop, for, and a for each loop. So you need to use each specific loop type at least once in your assignment. So let's look at the problem description. So we have option A, which you're supposed to output the sequence, right? Then we have option B, where you're supposed to output the sequence, where you're supposed to still generate use the sequence formula, or that formula that you use for outputting the sequence. Then you use that formula here to get a value before and after the index that the user has entered. Then you have option C, which your program must output a string provided by the user in all caps and in reverse order. So this string, you must do two things to it. You must capitalize all the letters, and then output those letters in reverse order. Then the last option is to exit. So the fact that you have this option called XX here, which is exit, we can't ask the user to exit, which makes no sense to just simply, let's say the program starts, right? And then we now start asking, hey, can you exit? It makes no sense, right? So this option here, they're showing you here so that you know that you need to use a loop. So you need to continuously ask the user to enter these options until they choose to quit the program or exit. So that's the first loop you're going to use. Then you'll use also other loops in the other options, which is basically option A, option B, option C. That's where you're going to use the other three loops, because option X just exits the loop. That's all it does. So let's open code blocks and start coding. Let's wait for it. Okay, so I'm going to create a new project, console application, because we're doing console applications. You might ask yourself, what is a console application? A console is the terminal. You see this black screen here. We call this the console or the terminal. So basically, when you say you want to create a console application, you're creating an application that runs via this black screen. It's too early to be doing advanced things. For example, let me show you a project I'm working on. So in the future, right, which is next year, you'll be making apps with buttons. See, I'm working on a game here, the one with O's and X's. So you click a button and then you should just output game over or who wins, whatever. So I'm currently working on that. So I also started here with console applications. So you need to start somewhere. So we need to start making console applications. Then in the future, guys, are going to make what we call desktop applications. And then I'm going to click next, then I give my project a name. So computer science 1A 1A P04 memo. Yeah, I think this should be fine. Okay, let me also put my company name here. So Vortex Academy there in the front, and then yeah. So now I'm gonna name my projects like that from now on. Then I'm gonna go to view and then manager, because I want to see this panel here. Then I'm gonna go down here. Make sure sometimes you guys press on other different things. I don't know why you do that, but sometimes you can press on wrong things. Let's say you press on files. You see now showing a different thing. So if you happen to be seeing something else, usually students see this. If you see resources, right, it means that you're in the wrong place. You have to go here and press that arrow to go back until you find projects. Then you click on projects, then you double click on sources, then main.cpp. And then there's your project, right? So let's look at our practical. We're supposed to have these options, right? But before we do the options, remember this whole thing of you asking the user to enter an option, it needs to be repeated until the user enters option X to exit the program. So that means before I do everything, I need to put a loop. Now the question is, what type of loop should I use? Based on this question, right? You can either use a while loop or a do while loop. Those are the only loops that are possible. You can only use a while loop or a do while loop. So let me just fix something here just in case someone enters the meeting and they didn't mute. So let me say do this, save these changes, and then close. So the question is, which loop are we going to use? For me, I've experienced, it's kind of obvious which ones to use, but you can use one of these two, a while loop and a do while loop. Why a while loop and why a do while loop? Because we don't know how many times the user is going to run this program. Basically, how many times they're going to test and enter these options. We don't know an exact number. You only use a for loop or a for each loop. Yeah, for loop or for each loop when you're 100% sure of how many times or how many things are there to count. In this case, we don't know. The program can start and the user can just simply exit. So that means the program can run once. Or the program can start and then the user runs it 16 times. So you see, there's no fixed number. So that's why I'm going to choose a while loop or a do while loop. But then in this case, what's the difference between a while loop and a do while loop? A while loop can run 0 or more times. That means a while loop can actually start without even running at all. So there's no need for us to use that one in this case because we need our program to run at least once, to basically to ask a user to enter an option at least once. So therefore, I'm going to use a do while loop. So I'm going to say do. What's going on with my keyboard now? Okay, so do while, right? And then we're going to have some condition here. So what will be that condition? So remember what stops the program? It's when the user enters the value X. That's when the program stops. So I'm going to create a variable and notice where I'm creating the variable. There's this thing called scope, right? Scope basically means that something's only accessible within those bounds. So what defines a scope in C++ is what we call curly braces. You see these curly braces here? Those are the things that define a scope. So anything within this curly brace, if you declare it within the curly brace, you can only use it within those curly braces. You try to use it outside, it's going to crash. So you see this condition for while, you see that it's outside of this curly brace. So it's outside. So that means I cannot declare that char variable that stores my option inside here. I have to declare it outside the loop. So before using the loop, I'm going to declare my variable that stores the options that the user enters. So I'm gonna call it choice. And then I'm gonna initialize it to null, meaning it's gonna be empty, it's gonna have nothing. That's what that means. And then there's something very important that you guys need to understand. You see that people are very unpredictable, right? You see, it says option X or option C or option D or whatever the option is. Someone can enter a small letter or an uppercase letter. So you need to accommodate both scenarios. So to avoid having to choose scenarios, right? To having to choose whether to hey, this guy keeps on joining. Hey, what's going on? Is it the same guy? Oh, mm, oh, you're saying your names start with N, look like the same guy. So when the user can enter in a uppercase letter X or a lowercase letter x. So they can enter uppercase letter x, or they can enter a lowercase letter x. Both of these are x's, right? So we need to accommodate for both scenarios. So for both cases. So you can, it's up to you how you want to solve it. There's many ways to solve it. You can say case and then you check for uppercase letter, then smaller case letter, lowercase letter. That's up to you. Me, I'm going to use what is this? I'm going to use something there's something that we call a function. So just like in maths, you see, if you still remember maths, f of x, remember that's a function, right? Which takes in a value of a parameter or something called x. So if you say f of 1, it gives you a result, right? So it's the same thing in maths that we're going to apply here in coding. So there's a function that we're going to use, which is called to lower. If you want, you can also use to upper. There's also is lower. There's also is upper. There's those 4 functions. They are found inside the header file called cc type. So you're going to say hash include cc type, right? They are found inside this file. So you're going to tell the preprocessor, which is a program that does what you want it to do. So I'm telling it, listen here, it means go fetch this file here and include it into my project because I want to use something inside of that file. So the thing that I'm going to use is this function here, these functions, right? So we have a function called is lower, right? This one checks if a char is a lowercase, right? It checks if that specific char is a lowercase. So basically, I wouldn't say necessarily returns Boolean, but I want you to picture it in that way. It returns true if the char is indeed a lowercase letter, and it returns false if it's not a lowercase letter. Then we have is upper. Remember, inside the round brackets, you pass in the char. So you're going to pass in that char here. It's actually an int, but we don't have to go into those details. Just want you to view it as a char. And then checks if a char is uppercase, is an uppercase letter, right? Then we have a to upper, which you also pass in the char. This one doesn't check. This one gives you back the char in uppercase letter. And then you have to lower. Don't worry, I'm going to send the code in the group. So this one gives you back the char in lowercase. So these are the 4 functions that we're going to use, especially when it comes to strings and char and the options, because you see we have a char here. Remember what I talked about. The user can enter a smaller letter x or an uppercase letter x. So I'm going to use either a to upper function or a to lower function to force it to be the case that I want it to be. So for me, I'll use to upper. It's up to you. You don't have to use to upper. You can use to lower. Like I said, it's optional. You choose the way you want to solve it. The way I'm going to do it, don't worry about the question marks. We'll get to that. So now we need to check. Remember, the program exits when the user has entered X. So a while loop, the way it works, it runs at least once. So this do keyword, it means do everything that's in between here while this is true. Yeah, you can ask your question, Jabulo.
So sorry. I wanted to ask if the like to use all these 4 functions, we need to have the what do you call it? The include CC type thing.
Yeah, so basically, I want you to view these things, right, as like you're telling what is a program called the pre-processor to grant us permission to use those functions. If you just use them, it's like, for example, it's like you went, how do I put it? It's like you went into a place whereby you're not permitted to go to. Remember, there's legal consequences and things like that. So Yeah, that's it's very important to include here to tell the preprocessor that listen, I want you to grant me permission to use these things. Because if you don't, in a way, that's another way of looking at it. But the way I want you to view it is like, in order to use these things, right? They're inside this toolbox. So you can't start using something without fetching it from the toolbox, right? So I'm telling the preprocessor here to go fetch that toolbox because I want to use some tools from that toolbox. And those tools that happen to be stored in this toolbox named CC type. Do you understand?
Yeah, I understand it now.
Yeah. So it's always the case. Trust me, it's gonna be. You see here in second semester, they might have something like this, like includes that are like this or different names. So for now, it's like still basic. So yeah, just get used to including. That's C++. That all languages have like that. Even Python, Java, all of them you include. Let me show you the Java project that I'm working on. If you check here, you see in Java, you use import. You say import, which basically means hash include. It's just a syntax, it's like a different flavor. It's like there's Coca-Cola and then there's Sparletta. Still the same thing. It's a fizzy drink. It's just different flavors. So just get used to including. That's how it works. So you might ask yourself, how did they, why are they expecting you to remember all these things? It's impossible. And of which you are right. So you can go to cppreference.com. CPP stands for C++. Then you just search here for a function that you want to use. For example, to lower, you go to the search bar here and you search that function. You click search, and then you should find the header file. We call these header files. This here, they're called header files. So I'm gonna choose here, and then the thing is, it's very hard to find, you see. But then there it is here. It says it's defined in the header CC type. So that's where it's stored. Remember what I was talking about? That it's not actually a char. You see, it's actually an integer, and it returns an integer. That's something very important that you need to understand. It gives you back an int, an integer, and you're supposed to pass in an integer. But then it's fine because there's this thing called implicit casting and all those things. We can leave it like that. There's this thing called implicit casting. So it'll basically convert our char to an integer for us. We don't have to worry about that. We just pass the char. So we'll do intensive revision on C++, right? Because now you'll be working on practicals. From now, it's solely you're solely coding. Even the exam is code again. So it's just coding one way. So we need to start from scratch and break down everything. I'm going to explain everything properly. The data types, casting, all of those things. So what I'm going to do is here, right? I'm going to use the to upper function. You see, it even tells me that it gives me back an integer. So I'm going to press enter, put in brackets, then I pass in that variable, which is choice. So I'm going to convert choice to what is to upper. But then you see that when you do it like that, yeah, but it's fine. I don't like what I'm doing right now. It makes the code very ugly. I don't like it, but it's fine. We're just gonna stick to that. So you convert it to an upper, but you need to remember this gives you back an integer. So you need to cast to test it out, right? Let's test it out. Let's delete that. Let's say C out and say to, and then here I'm not gonna initialize it to null. Let me initialize it to C. And then I'm gonna say to upper. Sometimes, I don't know, C++ is weird. Sometimes you think it's not gonna work and then it works. Sometimes you think it won't work. Um, or you sometimes think it will work and then it doesn't work. But yeah, you see, I'm right. It returns an integer. So we need that integer that it gives back to us. We need to interpret it as a char. So that means after returning, you need to cast it. There's two ways of casting. This is unsafe, right? To cast this way. So to cast this way, you put it in round brackets before that variable or that thing. Then you put in the data type inside of the brackets. That's casting. So it's gonna give back give us back the integer number 67. You might ask yourself, how does it know that that's C? It's an uppercase letter C? Well, there's this thing called, remember computers, they can only speak in numbers, zeros and ones. So how would it represent letters in the computer? It uses something called ASCII table. So the ASCII table, basically, in simple terms, is that each letter has a number, has an integer to represent it. And you can see 67 is an uppercase letter C. Small letter C is the integer number 99. So there's this thing called ASCII. So when you pass, trust me, they know what you're doing. It makes a lot of sense to do it this way because you understand C++. You see, now it's showing me uppercase letter C. So since we now understand these functions, all of them, all of them, they do integers and whatnot. So we have this. So the safest way of casting, right, it's to do it this way. You say static underscore cast, then you pass in the type inside angle. We call these angle brackets. Then inside the round brackets, you pass in that variable or that thing. In this case, you see, in this case, that variable is the call to this to upper function, because that to upper function will give us back an uppercase letter, but then it's gonna give us back an integer. Then we convert it back to a char. So yeah, I know it's a drag. I know it's really annoying, but you just have to do it that way. So I'm gonna do it this way. I'm gonna do this and then put back that do while loop. So do while, then I'm gonna put back, in the condition, right? Remember, I want a char. So I'm gonna use to upper. Then after using to upper, I cast it back to a char because to upper is gonna return me an integer representation. Basically, it's gonna give me the integer that represents that letter. Me, I don't want the integer. I want the letter itself. So I'm gonna cast it or convert it to its equivalent letter. After it has been converted, this whole thing up until here, that represents that letter, right? Then I can check it and say, while that letter is not equals to uppercase letter X, continue running, right? So because it should stop when it is equals to X. So what happens when the user enters a choice of X? It's gonna come here and test and check, if this is X, right? X is not equals to, it's false. X is not equals to, how do I put it? English. It's false that X is not equals to X. X is indeed equals to X. So this statement will be false, and then the while loop stops. So it looks untied. I know. Trust me, I know. I don't like doing this way, but you have to do it that way. So this will be your while loop, right? Then here I need to put back null to initialize it to nothing. Then now we can, number one, what's the first step that we need to do? We need to list the options to the user. It doesn't make sense for you to use an app and you don't know what to do, right? So that's why we need to output the options or the choices that the user has. So I'm gonna output them. So cout option A. Then what is option A? Okay, let me put in that letter there and say A. So option A is what output the sequence, right? And then I'm gonna put in an end of line character there. And then remember what we talked about. If you're putting an end of line character there and you don't want to keep typing cout, make sure you don't put a semicolon here. If you put a semicolon there, it's gonna crash. So I don't want to keep typing cout. I want to use one cout. So I'm gonna go to the next line and then just don't put cout. C++ knows because it's gonna continue reading, right? Until it goes down to the next line, until it sees a semicolon. So far, it hasn't seen the semicolon. So it's gonna allow me to continue typing. So I'm gonna have option B. which is to output number before and after index, right? Then I'm gonna put in the end of line character. The end of line character, remember, is so that we have each sentence on its own line. If we don't put the end of line character, this is what's going to happen. It's going to take option A, right? It's going to be option A. It's going to be option, yeah, it's going to be option A, outputs the sequence, and then option B. So it's going to be like this. You see, that doesn't make any sense. You can't read it. So end line, it means when you're done outputting the first sentence, that's the end of that line. So that means the next part, when I output another string, it's going to output it on a new line like this, so that we have rows. So that's why it's important to do that. So I'm gonna keep on putting that end of line character so that my output looks pretty. So option C is to reverse, okay, is to output a string in all caps and in reverse. And then we're gonna put in the ENDO to end that line. Then I'm going to, so this is so far the output. Then I'm going to do option X. Then option X, this is where you exit the program. And then don't forget to put the end of line character, right? Then now once you're done, right, you can now get the input, right? So basically now you can get the choice from the user, or get the user's choice. Get the user's choice. Basically what the user wants to do, their option, which option are they choosing? So I'm going to use cin, and since I'm getting, so it's incoming, right? I'm going to use the stream extraction. You see the direction. It shows the way it's going. So it's coming from here and it's going to be stored inside a variable. So that variable is called choice. This is one way to do it. Then there's another way, calling the get function. So you say dot get. I prefer to use the get function, so I'm going to use that one. It means exactly the same thing. So get, it means when you use the get function, it gets one character from the buffer, right? Or from the input stream. Basically from the buffer, yeah. So it gets that one, or exactly one character. Remember, we have get line method to get the whole line. When you call just get, it gets one letter or one character. So I'm going to use that function, get. Then I'm going to show you the problem with this, right? The user, we can see the options, right? They're there, but then the user is not intelligent enough to know that this line here that keeps on blinking here, that's where I should start typing. They wouldn't know. So you need to tell them, output a string and tell them enter your choice or something like that. So after displaying the options, I'm gonna output an end of line character. I don't have to actually output it here. I can just output it there. Let me output it there. Let me output another end of line character. This is just to format the output so that it looks good. Then here I'm going to say cout, and then I'm going to say enter your choice, right? And then I do not want to put end of line character here because why? I want the user to type within this, on the same line where this string will be displayed. So if you see it now, when I run it, I'll be able to type on the same line. You see, I can type on the same line and say option A like this, right? Instead of, if I had put ENDL, it was gonna ask me in the next line, which is wrong because we want the user to enter here. So this is okay, I don't need this, so I'm gonna close that for now. So there's something that you guys were supposed to take into account and take it very seriously. There's 5 marks for validating user inputs. So what does that mean? Validating user inputs, it means that you're checking if what the users entered is what you expected. If it's not what you expected, I would put an error message. So we need to output an error message to the user. So it's up to you whether you want to output the error message and then exit. That's up to you. Or you want to output an error message and then allow them to continue. There's no specific requirement in the practical. So you can choose to do whatever you want to do. I would choose to just continue the app. But then, yeah, remember we talked about switch statements, if statements, and then the ternary operator, this one, or the conditional operator. Here, the one that we can use is the switch statement because we have multiple values. Remember, switch statement is to check values in a variable. So I'm gonna say switch and then pass in the choice there. But then remember, we talked about this. The user can enter this choice in uppercase letter or in lowercase letter, which is a problem. So we need to cast it. We need to basically we need to start by converting to an uppercase or lowercase. In your case, it's up to you. Be consistent with what you choose. So if I had used to lower here, right? If I had used to lower here, I'll compare it to this lowercase letter x, not uppercase letter. That's up to you which function you use. I'm using to up. That's how I'm choosing to solve this problem. So, okay, here I'm going to do the exact same thing that I did here. And then, yeah, it looks untied. Trust me, I don't like doing this, but yeah, C++ is kind of, I like C++, my favorite language, but it's kind of like bad for beginners because it's too complicated for beginners. So we have our switch statement, right? So we're going to have our cases. But remember, I used the to upper function. So that means the only letters that I should compare is uppercase letters. So I can ignore the lowercase letters. So if it happens to be a lowercase letter, the to upper converts it to an uppercase letter. So I'm going to say case A, uppercase letter A, and then break. Then I'm going to say case, uppercase letter B, and then break. And I'm going to say case, uppercase letter C, and then break. And then I'm going to say for, yeah, let's put case X. Let's put it, and then break, and then we're going to have default. The default, it means that it was none of the above. It means that, remember in the practical, there's marks for checking if the user entered something that's incorrect. So if they enter an option that does not exist, you need to tell them. That's where the default part comes into place because default means that it was none of the values above. So that means choice, it neither had the value A or B or C or X, meaning that the user entered an incorrect option. So we need to say CR, right, to output an error, and tell them incorrect choice entered, right? And then output the end of line character. Then, like I said, it's up to you whether you want to exit by calling the exit function or you want to continue. That's up to you. Me, I'll let the user continue. So I won't do anything here. I'll just output the error. Done. In my case. In your case, I don't know how you're choosing to approach it. And then in the switch statement, right, under each case, I would advise you to put curly braces, right? So after the colon, press enter, then you put curly braces there, enter curly braces, because I don't know, for some weird reason, sometimes if you don't put them, C++ tends to have issues or errors. So I would advise you to always put them because you're bound to also have multiple lines. And I want you to notice something about my code. It's neat. Make sure your code is neat. Look at how neat my code is. Everything is aligned. So make sure your code is neat. So let's do option A, right? So output the sequence. Remember, we've handled for the case when the user enters an incorrect option. So we are done validating the option part, right? Then we go to option A. Yeah, you see option A and option B, those are very annoying things to do. You'll see why. Because remember, there's marks for validating user inputs. So you need to check if the user entered a number. Remember what I told you, that the user can enter unpredictable data or information. So for example, let me build and run. You tell them clearly that these are the options, and then the user decides to enter a 9 and then press enter. So you see that becomes a problem. Okay, something is wrong here. It's output. Okay, incorrect option entered. Right. Yeah, something is not right. Let me do this. Let me go back here and check something here. So we have this, right? And then we check here. In this case, these are entered an incorrect option. Then we simply output an error. Then we check the condition here. And then we go back up to the top. And then we output this. And then also output this. I'm thinking about it. Let's do this. Let me do this. Let me just test. I'm not sure if this is the issue. So let me do this. I'll explain if it did fix the problem. I'm trying to understand why it's outputting. You saw that it's outputting the output twice. So let me press 9. Yeah, so it's something that has to do with the buffer, right? So what happened is that, you see what happens, right? It's a very weird. You need to understand the buffer. Understanding of the buffer is very important. When you enter an incorrect value, right? Technically, we can say, what is this? Your program has entered a fail state, right? In the textbook. That's how it's defined. Meaning something went wrong, right? It failed to do something right. So even though it failed to do something right, this value 9 is still sitting there in the buffer. That's the problem. So we need to remove that 9 and basically clean the buffer and then use it again. So in this case, I want you to picture it in terms of like a plate. I mean, after eating, you're supposed to wash the plate, right? You can't tell me that you use a plate and then you don't wash it the whole night, right? And you go to sleep. Tomorrow morning, you still haven't washed it and then you dish up again. You most probably were not gonna do that, right? So you need to clean it first before using it. So it entered a fail state, meaning that there's two things that we need to do. We need to say cin dot clear. If I'm not mistaken, this is cin dot clear, right? Yeah. This restores the, what's that terminology? I forgot the English that they use, but it enters a fail state, right? We're undoing that fail state. So we're putting it back we are restoring it into its normal, to the way it normally was. So that means it's no longer in a fail state. But then before we continue, we need to clear the buffer. So I'm going to say cin.ignore. And then ignore, it means ignore everything up until a specific letter. So we specify how many characters we need to ignore. So let's say we enter 100. It means that it's going to ignore 100 letters. You can read it that way, 100 letters, up until it reaches the character end line, right? Remember, \n is another way of saying end line. Remember, when you enter your input, you press enter on your keyboard, right? So when you press enter, what happens is that it also adds that end line into your buffer. So we need to delete everything up until that end line, basically cleaning the buffer. But then it works, right? You see, this will work 100%. But then if you want to clear the buffer fully, right? Like full, you see that it expects you to pass a stream size, meaning the size of the stream that you want to clear. Basically, how big is the thing you want to clear? In this case, I just said 100 letters. So the way it's going to work is that it'll clear everything until it'll clear the first 100 letters, right? But then if the letters are less than 100, it's still gonna clear them, but then it's gonna clear until it reaches the \n, right? So this is I would just advise you to stick to this method. It's fine. Don't choose that one. There's another one, the proper one, numeric limits, using numeric limits. There's that one. I wouldn't advise it using this now. It's too advanced. Not gonna lie to you. It's not even in the textbook. That's how advanced that thing is. It's not, they didn't put it in your textbook, so don't put it. So I'm going to run now, and then I enter incorrect option, right? And then you see it doesn't repeat my output. That means it cleaned everything in the buffer. So now I'm ready to get the next input. So you're gonna keep repeating these two lines. Every time something goes wrong, you get input that you didn't expect. So here you just restore the buffer from the fail state, right? Basically, you take it out, or you are removing it out of the fail state. Then once it's out of the fail state, you clean the buffer. So here, cleaning or clearing the buffer. Clearing the buffer, that's up to you how you want to view it, but I would say cleaning it, but let's just say clearing the buffer, right? So yeah, then we 100% good to go. Then now what I need to do is I need to, what is this? Do option A, right? So what is option A? So I need to enter the number of terms, starting number, and common difference. So I'm going to create those three variables. So I'm going to say int number of terms is equals to 0. And then int start number. We just give it a value of 0 for now because we're getting it from the user. I'm just giving it the default value. You need to normalize initializing your variables. Common difference is equals to 0. Then now we get the values, right? So here we're going to get the values from the user. So now we're going to get the values from the user. So let's get them one by one. So before you get the value, you need to output a message so that they know what they're entering. So enter number of terms. And we don't want to put in the end of line character because we want them to type on the same line where the string is displayed. And then I'm going to get the number. So cin, remember the get, right? You only use it when you're getting a char. Only. Don't use it when you're getting other things. So I'm getting an integer now, so I'm going to use the normal way that we've been doing it. Then I'm going to get the other two values. So I'm going to do this. And then two other values. Don't copy and paste because you need to know how to to update your code. So here, and this should be start number, and then here should be common difference. So enter common difference, and then here it's going to be common difference, and then before we even actually start working, that's why I say this thing is really annoying because yeah, there's a lot of checking. What if the user enters something that's not a number? It enters a fail state again. So you need to test for every part. Let's say we enter option A, right? Cool, everything is fine. Then the user decides, let's say it's you give your grain, she decides to enter hello instead of a number. And then what's going to happen is you see what happens? It has entered a fail state. So that's why in the practice they say you should handle for when it enters a fail state. So after I've gotten every number, I'm going to tell I'm going to check if it has entered a fail state. So if cin.fail, that's how you check. That means you see cin. Remember, cin represents our input stream where we where the numbers that we entered are stored. So if the input stream, the number that we stored, and we try when you try to get that number from that input stream, it failed, then we should do something. That's what we are checking if it failed. But then remember this checks it only once. let me show you the problem with if statements. Remember, only in this case, there's a problem with the if statement, only this scenario. Let me show you why. So remember, it enters a fail state. So I need to restore it first from the fail state. Or basically remove, what is this? What's the right term for it? Remove it from the fail state, not remove it, but yeah, let's just say restore it from the fail state. Basically, it has entered a fail state. You want to exit that fail state, basically put it back to normal. So you say cin dot clear, right? After you've restored it from a fail state, then now you can clean that buffer, make sure there's nothing inside. So cin dot ignore the first 100 letters until you see a end of line character. So like I said, if the number of characters that are there is less than 100, it will actually never reach this because it will stop when it has reached those characters that are currently in the buff. But if the characters that are currently in buff are more, it's gonna wait until it sees a backslash n, meaning it's gonna remove everything, even if there's like 4,000 characters. It's gonna remove all those 4,000 until it sees a backslash n, meaning a new line, meaning until you've entered on your keyboard, you pressed enter. Until you pressed enter on your keyboard, it's gonna keep deleting from that path. So before we do that, I need to output the message and let the user know what happened. So I can tell them incorrect number, incorrect value entered. Then I'm gonna tell them, please enter an integer. So I tell them what went wrong. So he entered some incorrect value. Then I offer a suggestion so that they know what to do. Then I tell them, please enter an integer. Then ENDL to format the output to make it look pretty. Then after we're done with that, we clear the buffer, we restore everything back to normal. These two lines, right, in simple English, we're restoring everything back to normal. If you don't restore everything to normal, you see what happens. It's going to keep outputting on the screen those lines. So, but then we're still not done yet. Let me say A, and then I enter K. You see that you see now it works perfectly fine. It's telling me incorrect value entered, please enter an integer. But do you see the problem? It's not offering me an option to enter the number again. So I need to ask the user to enter the number again here. So after restoring it from the normal, then here, this is where, don't worry, I'll send the code in the group. Here I'm gonna clear the buffer to make sure it is empty in order to get more input. Do you know why we need to clear the buffer? Because if you don't clear it, the next time, if you try to get an integer again, that K or whatever hello you've entered is still in the buffer. So it's gonna crash again. Then you try again to get it's gonna crash again because it's still hello. So you need to remove it and clear it. Then once you're done, then you can ask the user to enter the number again. Basically try again. Then I'm gonna copy this and put it here because those are the two lines for getting the number. And then done. But then, like I said, an if statement, right, it runs only once. What if when you give them the second opportunity, they still enter a stupid thing? So yeah, users are very unpredictable. So I'll show you how to handle that. You simply change the if statement to a while loop, meaning as long as it's still in a fail state, meaning you're entering incorrect things, continue asking the user until they enter a right thing. So let's say you enter K, right? And then it gives you a second opportunity. Then I enter O. You see that something goes wrong entirely. So you need to continue. You need to use, you see, now it's weird output. I don't even know what's going on now at this point. So that's why it's important to understand what you're doing step by step. So here I'm going to remove the if and change it and put a while. We just says that while, so meaning, remember while, it continues running as long as that condition is true. So while the scene has failed, meaning while the user is entering spiritual things, incorrect answers, continue outputting this. Start by output telling them what went wrong, clear the buffer, restore it from the fail state, clear the buffer, ask for input again. Then it goes back to the top. Did it fail? Did they enter an incorrect thing again? If they did, continue. So this continues to infinite, as long as you keep on entering stupid values. So let me show you. I'm gonna enter A, A. You see, it keeps on asking you until you enter the right thing. Then I enter a number 9, and then boom. You see, I want you to notice something. It's now asking for start number because I've now entered something that looks like a number. So now that counts as a valid input or correct input. So we are done doing that. So that's why it's important to understand and test your. You see what I'm doing? I'm changing one little thing and then I'm testing it. That's how you should do it for your practicals. You should put one thing, test it. But then this code is going to be a lot because I'm only testing number of terms, but there's also that number. But there's also common difference. So yeah, your code was actually supposed to be a lot in this practical. Then I'm gonna have another while loop here, but then this time around I'm testing start number. So I'm only gonna change these 2 lines here. And then I'm going to copy this, put it at the bottom here because common difference the user can enter a common difference that is not a number. So you need to also validate and test that to make sure they enter a number. Yeah, and then you're done for option A testing part. But then let me now put my comments. So I'm going to say validate number of terms. So I'm validating, it means you're testing it to make sure that it's in the right format. Basically, testing if it's a number. If it's not a number, you ask for input again. So validate that number. And then here, validate common difference. Common difference. And then we are done testing, right? I know it's a lot. Trust me, I know. See, it's a lot. It's really a lot. Look at all these things. It's a lot of testing. Then now we can, now if it reaches this part, you see line 84, it only reaches line 84 when all 3 numbers have been entered correctly. So that's why I'm assuming at that line that everything has went well because it will only go to that line if everything went well. So now I can output the sequence. Then now I need to use, since I'm outputting a sequence, I'm told the number of terms. So I know the exact number of things I need to display. So this is where a for loop is used. I know the exact number because I asked the user to enter the number of terms. Then I have, what is this? For example, the user enters 6, blah, 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 all these things. So what am I thinking about now? Oh, so we need to start number, blah, blah. Okay, so number of terms, we have that. So now I need to use a for loop. So for int I is equals to, here you always put the start number. And then I is less than, here you always put the number of things here. Less than the number of things. What number of things are they? In this case, I have number of terms. So number of terms. And then I plus plus, meaning increase by 1. Yeah, remember I plus plus just means add 1 to the start number, meaning move to the next thing. Basically, I plus plus counts. So this is how I plus plus works. If your starting number here, I is 0, if starting at 0, then it's gonna I plus plus is going to basically it's going to basically 0 plus 1, which is 1. And then I is now 1. And then I plus plus again, that's I plus 1, which is 1 plus 1. So that's 2. So 2. And then 3, 4, 5, 6. So it's basically counting. So that's what this part does. It's counting. Then we have here, we need to put in the starting point or the start number of which we got, we had it, we got it from the user. So it's called start number. And then these are the number of terms. Then now we can output the number, right? So how do we output the number? So you see that I start, let me see. Yeah, we're starting at T0, right? In this case, if you remember high school, you're finding the general term. So you have you have T1, T2, basically term 1, term 2, term 3, and so forth. So in this case, they want you to assume that it starts at T0, which is term 0 in this case. Then that's fine. It doesn't make any difference. So you see that at each term, you see the common difference was what? Look at the common difference, 2. So if this is the sequence, right? Let me open it in Notepad first, so that you can see what I'm seeing here. Maybe you might not see it, but let me put it here. This is what? Oh, this is C++. So I have this sequence, right? Remember what I said? They said you should assume that the first term is term 0, not term 1, unlike in maths. They want you to assume it in that way. So 1, 2, 3, 4, 5, 6, and so forth. So at T0, my value is 0. So that doesn't tell us much. We can't find a common difference, right? Remember, in this case, I'm applying this formula. Just to remember this formula, where D is the difference. So I'm using that formula. So you see, it went from 1 to 2. So I can assume that it's that term, right, which is T1, and then I added 1. I can assume that's how they found the number. Or I can say maybe they say T1 times 2. You see, those are the two assumptions. So at this point, I'm not 100% sure yet. Then I go to the next term, term 2. The value for term 2 is 4. So it also kind of, so far I'm seeing one common thing. So let's say it's term 2, right? To get that value, maybe I would have added 2, or another formula would be to multiply 2 by 2, which gives me 4, or add 2 to 2, which gives me 2. So far I'm seeing this common formula. Let's see another thing again. 3, how did it change to 6? You can add 3, but then, or we can multiply it by 2. So we see that the common thing here at the end of the day ends up being multiplied by 2, of which that multiplied by 2, if you check in the practical, that is what is called the common difference. They said if the user enters these 3 values, 6 is the number of terms, 0 is the start number, 2 is the common difference. So that means I multiply I by the common difference. So I'm going to say C out I times common difference, right? And if I just leave it like this, right, you might think, no, you're killing it, you did it, everything is right. Look at how ugly the output is going to be. It's going to work, I agree, but the output is going to be ugly. So our number of terms is 0, start number is 6, start number is 0, common difference is 2, and then boom, there's the numbers here. You see, there they are here. It's the correct numbers, but the output is not clean. It's not proper. So one thing I need to do is I need to fix the outputting of the numbers. If I leave it like this, it appends them together. It kind of looks like one number. So if the first output is 0, it puts it there. And then you see here at the end here, there's no space here. So that means the next number is going to be displayed immediately after that number. So 2, and then 4, and then 6, and then 8, and then 10. So you see, we need to put spaces after each number. So I'm going to say also put a space like this. So that now when the number is displayed, right, when it sees 0, it puts a space. And then it displays the next number, put a space. Next number, puts a space, and so forth. So you see now the number looks proper. But then we also need to, once we are done here, we need to also output the end of line character outside the loop. Once we're done outputting the numbers. Okay, so for me, I'll put 2 end of line characters. I want my output to be to look real pretty. So I'm gonna say a 6 terms 0 starting number 2 is common difference. So there's the numbers, right? But then it's still not proper, like still really not proper. Oh, you see another thing here, incorrect option entered, blah, blah. We also need to fix that, cleaning the buffer. You see, cleaning the buffer is important. It's outputting weird things now. We need to clean the buffer, but we'll clean that later after we fix the output here. So what I want, you see here, after displaying common difference, I want to output an end of line character so that these numbers are on their own line. Then these numbers, before they are displayed, I need to output a text saying what these numbers represent, right? So I'm going to say they represent a sequence. So remember what I said, after getting the common difference, which is here, after that, I need to output an end of line character to make my numbers appear on their own. Then after the end of line character, I need to output a string to specify what are these numbers. I'm going to say the sequence is semicolon. Do not put end of line character because it's going to display the numbers in the next line. I don't want that. I want it to display here. So it's going to say 0, 2, 4, and so forth, right? So that's why I'm not putting end of line here. So let's test it one more time. And then A, 6, 0, 2. And then there's the sequence. So the sequence is, boom, there's the numbers. And then for option B, now we go to option B. Option B, remember, is exactly the same as option A, except for that we're not outputting the sequence anymore. We're still calculating the sequence, right? But we're not outputting it. We're trying to find a number before or after that index. So I'm going to do this. I'm going to copy from here up until the beginning there, here, right? So I'm going to copy everything. Yeah, don't be like me. Don't copy and paste if you don't know what you're doing. Me, I can see curly braces. I'm sure so far you know that I know what I'm doing because we haven't seen an error in my code. There's no line where there's a red line. There's an error, right? I know what I'm doing. So don't try to copy and paste if you don't know what you're doing. Type everything from scratch. So here I'm gonna have the fourth variable, which is index, right? And then we need to also get the index. Like I said, don't copy and paste like me if you don't know what you're doing. So I'm going to copy and paste. Let me zoom out a bit so that you can see where I'm copying. So I want to copy from here, right? And then here I'm going to say enter the index, right? Then here is going to be the index. And then here at the bottom, I'm also going to change that to enter the index. And then here it's going to be index. And I've validated, everything is fine. Validation, everything is there. So now we can go to the sequence, right? So now I can output the number before and after. But then before I do that, remember to make the output look pretty, in the previous, I put 2 end of line characters here. And then we need to output the number before and after. So I need that for loop again, but then it's fine. I can still type it, it's fine. So I'm going to say for int I starting at start number, I is less than number of terms, and then I plus plus, right? And then remember I represents the term. Another word for term is index. So here I'm only looking for that specific index. So I need to do a check, an if statement. So if I is equals to the current index I'm looking for, right? So here I'm going to check if I is the index I am looking for, right? I'm gonna basically ask the question: Is I the index I am looking for? If it is, then I can output the number before and after. But if you check the practical, right, learn to read the instructions of the practical. They say note if the index is at the edges, meaning it's at the beginning or it's the index at the end. Basically, you are looking at the first term or the last term. If you look at these numbers properly, right, I want you to use your the critical thinking skills. If index points to this number, you see that there's no number before it. So that's what they want you to think about. There's only a number after it, which is 2. And you look at 10, there's no number after it. There's only a number before it. So that's what that note was trying to explain this part here. They're trying to say, and then they tell you what to do if you're at the edge, beginning, end, or at the end of the sequence. Only print the valid or available values. So that means I need to also do an if statement that again to check, right? If I am at the end, how do I find if I am at the end? So before I do that, I need to create two variables to remember. I need to output. Remember to output a number. We're using its index or its term number. If you look at the previous option, right? Where is it? Yeah. If you look at the previous option, we're using I, which represents the term number, and then you multiply that term number. Basically, term 2 multiplied by the common difference, which is 2, to get the number for the term. So we are doing exactly the same thing, but we need to find I, the term, for the term after and the term before. So I'm going to say int term before. So how do you find the term before? You take the current term and you subtract 1, right? I hope that's straightforward. Let me show you what I mean. Sometimes things are not straightforward for everyone. So term 2, how do I find the term behind it? It's term 1. So basically, how did I move from 2 to 1? I had to subtract 1 from that term. And then the next term, or the term after this current term, is 3. That's the term after. How did I move from 2 to 3? I added 1. So that's the math behind it. And then int the term after, I simply take my current index I, add 1 to it. Then now I need to check if these terms are valid or they exist. If it exists, then I display it. So I'm going to check, I'm going to say check if the term before exists. If it exists, right? How do we know if the term exists? If, remember, if I, let's assume I'm at the beginning of the term. If I subtract 1 from 0, what do I get? This is simple maths. What do I get if I subtract 1 from 0? I get 1. I get -1, I mean. So you see that -1 is less than 0. So that means if I'm looking for a value before, it needs to be at least 0 and above. So that's the check. So I'm going to say if term before is greater than or equals to 0, at least 0, then I know it's a valid term. But if it's negative, then it won't do anything. It's going to skip it because that's what the if statement does. It only executes if this condition is true, meaning if that term exists. Then if it exists, then I can now output it. So cout term before. Remember the variable term before, it stores the term number. So I just need to multiply that term number with the common difference. And then remember the terms. Okay, in this case, we're not outputting a lot of terms, only outputting 2 terms. So I'm going to before I output the number, I'm going to output the string so that the user knows. So this will be term before. So this term before, and don't put end of line character because it's going to move to the next line. I do not want that. I want it to be displayed on the same line. And then I'm going to pretty much do the same thing to check the other term, if it exists. So now I'm checking if term after exists. So I'm going to say term after. How do I know term after exists? So the term after, remember 5. Okay, remember, let me see. remember this, I want you to see a pattern here. So let me do this. Computer science is basically maths. If you know maths, you're sorted code com sci. Because you see, so far I'm doing maths, right? Taking it back to high school, general terms. So it's maths. So if you remember what we entered number of terms to be 6. So I want you to notice something. You can test it out. You can enter number of terms to be 5, but the last term will always be -1, the number of terms. You see here, the number of terms is 6. So the last term would be 5. 6 minus 1 is 5. So that means the term after should not be equal to the number of terms. So it should be less than the number of terms. If it is equals, if the term after is greater than or equals to 6, then I know it's invalid. It does not exist. So I need to make sure that that term after it's less than the number of terms. So that's why my condition here, I'm going to say term after is less than number of terms. And then if that's the case, then I can now display that term, because that means that the term exists. So term after, but then before I output, I want you to notice something here. Before I display the next thing, I need to output an end of line character here. I can picture, the thing is I can see the code in my head. Let me show you if I don't put that end of line character there. Let me show you. So let's say option B, 6, made a mistake. Let me cancel. I entered the wrong values. So I'm gonna say B, 6 terms starting at 0, difference is 2. Index I'm looking for is index 4. So the answers that I'm expecting to see 6 and 10. And then enter. It does output, right? It is working, but you can't see because you're not making your things beautiful. That's why it's important to make the things look beautiful. There's the terms. Term before is 6, term after is 10. It's correct, but the output, that's why I said after outputting the term before, you need to output an end-of-line character. Then after outputting the term after, you need to also output an end-of-line character. Here I'll just output 2 to make it the output more pretty, but 1 is enough. So B060224. So you see, there's the term before is 6, term after is 10, which is true. Because if you check here, index 4, what is the term? What is the number before index 4? It's 6. What is the number after? It's 10. So it's correct. It is working properly. So we are done with that, but they're not necessarily done, because you see, we're having issues here with the input, the buffer. I don't know why it's doing that, but yeah, we're having issues with the buffer. So before we do that, let me check something here. I don't need those 2 end of line characters there. Yeah, there's a lot of reasoning here. You need to reason, plan step by step, and see and test little by little. Then you should eventually get to where you want to go. Don't worry, guys, we're almost done. Yeah. And then it's going to go back here and check what's the value of 2 upper. Then it goes back to the top there, which is here. And then it outputs this. And then it tries to get the next choice, right? So what I would do is, right, since you see that it's showing errors, so what I would do is I'll say cin.ignore here. Right before getting input to clear the buffer, to make sure the buffer is clean. So let's see if it's going to take a take and okay, it doesn't. Okay, you don't put it there. Uh, where should we put it? I could put it here. Let me try putting it here. Yeah, right after we're done with everything, just to clear the buff and make sure everything is clean. I just want to be sure of that. So 6024. Yeah. So just make sure you clear the buffer. The buffer is annoying. You have to clear, I don't know. This thing you need to really see, plan and know what you're doing. So here we just clean the buffer before getting input. Just make sure we clean it so that it's clean before get the next input, because you saw that it was outputting errors if you don't clean it. Remember, you use cin.clear only if it entered the fail state, only if you entered basically incorrect or an incorrect choice or incorrect number. That's why you use clear function. In this case, we're only going to use clean to clean the buff. That's all. Yeah, because nothing went wrong here, right? So, and if it did go wrong, it was going to handle it here. But then we also do handle it here. So yeah, we're basically safe. Then I'm going to do option C. So option C, that's where we're going to use the for each loop. Why for each loop? Because a string is basically a collection of characters, right? So let me explain a string. So if you have a string like hello, right? C++ views it as like this. You have the char H, and then you have the char E, you have the char L, you have the char L, you have the char O, right? It's called a string of characters for a reason. You can picture these letters. You still remember those things that you bought at the mall, those name bracelets, right? So name bracelets, the ones whereby they give you letters and then you join them together to form your name. For example, you'd surprise your girlfriend or something. Uh, yeah, these ones. Remember that they were joined by a string, right? Come on. Uh, why is it doing this? Yeah. So you see that they were joined by a string. You see Avery, Ola. That O is its own char, its own char, its own char, its own char, and they were all joined by a string. So that's why it's called a string of characters. So that's where they took that concept. So a string of characters. So that's how it views it. So and it's zero index. So this would be a position 0, position 1, position 2, position 3, position 4. And then a string also has a function that you can use. You can use length or size, but I would prefer using size. So the size function that you can call returns gives you back the number of letters. In this case, the number is 5. So it's going to give you back 5 because there's 5 letters. 1, 2, 3, 4, 5. There's 5 letters. So if you use the size function, it gives you back the number of letters. Those are the few things you can learn about strings. So yeah. So now we need to get the string, right? So before we use the string, we need to include it. We need to tell the preprocessor that we want to make use of the string type. So include string header file so that we can, when you type string here, it's gonna know what we mean because we told it that we're gonna use the string here. So I'm going to say string, and then I'm gonna call it, what are we getting again? We're reversing some word or words, right? Then I'm gonna initialize it to an empty string, basically a string with nothing. Then I get input. So I'm gonna say cout, and then I'm gonna say enter the string, right? And then the user enters the string. Then you use the get line method, which gets the whole line that has been entered, including the spaces. Remember, you can enter the sentence, this is the best day ever. This is a sentence. So you see that it has spaces here, spaces. If you were to say cin like this and you say words, right? What happens is that it only gets this keyword. That's it. It only stores this. So that's not what you want. I want to get the whole line. So because that's what the practical says. If you check the practical, it does where does it does say, or maybe it was the previous practical, but it should say somewhere. Where did it say? It didn't say. I think I was looking at the previous slide, but it didn't. It should say something that you should account for spaces. The user can enter a space, right, including those spaces. Yeah, you see, you see, I was actually doing the right thing. Look at this note. Write messages explaining to the user what the inputs are expected. So basically, tell the user what they should enter, which is, for example, enter the string, enter the start number, enter the common difference. There's marks for those things. So yeah, I'm gonna use the getLine method and then cin. You pass in the input stream here, which is cin, the iStream object, which is cin, which stands for common input, right? And then here you pass in the string that should store that whole line. So it's gonna be words. So we're gonna store it inside the string words. Then let me try to display the string back to test if it's working. Input was right, and then cout words, and then and line character. So let's see if it is getting input. If it is not, then we know probably the buffer. You see, the buffer, it might need clearing and things like that. Hello. Yeah. So you see the buffer. You see the buffer. You see what's going on here. It didn't do the right thing. So we need to clean the buffer again before we get the string. Before we get the line, we need to make sure the buffer is clean. So cin dot ignore, then /n. Yeah, there's a lot of cleaning buffers here. So you need to clean the buffer. So you see now it works. This is the best day ever. And then it tells you that your input was, this is the best day ever, which is true. That was my input. But then it's still asking for input again. What did I do here? Did I enter two things? No, I didn't. Yeah, I didn't. Okay, let's do this. Let's remove this here, the one that cleans it there, and leave this one over here. I think if we clean twice, it also kind of like causes errors. So let's only clean it there on the string, and then see hello world. Yeah. So I don't know how you can master this thing, guys. I honestly don't know how, but I'll try to teach it when you do proper revision. We're gonna do it. I think we should do input and output. That's very important to understand. Getting input and output in C++. It's a very important. That's a very important to understand topic right there. So we know that our string is storing the right thing, right? We're getting the whole sentence, the whole line. So now we can go through each letter. So you can use the for each loop. So for each loop, right, it works in this way. You have that one thing here, and then you have multiple values here, multiple things, right? A variable that stores multiple things. And then you store that one thing at a time inside this variable. Excuse me. You store that one thing at a time inside this variable that you're going to declare here. Here you pass the name of the variable that has multiple things. In this case, it's our string words. And then it is these letters here. We're going to get one letter at a time. Then I'm going to create here. Remember what I told you here. You see the example. I'm using single quotes to tell you that each thing in the string is a char. It's of char type. So here I'm going to say char. And then I'm going to create a variable called C, right? So what's going to happen, C is going to work in this way. C is going to be initialized at the beginning to H, the first letter in the string. Then C++ updates C and moves to the next letter, which is E, and then updates, moves to the next letter, which is L, and so forth until it has read the whole string or the whole line. So that's how it works. That's how the for each loops works. It stores one value at a time inside this variable here. So now how do we reverse? To reverse, we need to actually create another string here called the string, we're gonna call it, what is this? Reversed, right? It stores the reversed string, right? How am I going to reverse the string? Well, I would advise you guys go and do the diagram of this thing and try to picture it one by one. So to reverse a string, right, I'm going to use something that we call in coding, we call it concatenation, right? To concatenate, meaning to join two strings to form one string. So basically, if you have H plus E, this would equal the string HE. Yeah, that's up to you how you want to picture it. You want to think about it in terms of of science, if you know what I'm talking about. That's up to you, but I just weird coincidence. Or you have hello plus world. This gives you one string called come on, how is it in this? Called hello world. You might ask yourself, right? How come you didn't put the space? You didn't tell it to put the space. It takes everything literally. So you need to put the space right before world like this, so that it puts that same space right before world, so that the one string looks like this. So I'm going to use this property of adding strings. So how do I reverse a string? So using this property, right, let me show you how the formula to reverse a string. You have a string like this, right? How can we reverse the string? We can actually do it this way. Remember, we have that variable c, and then we have an empty string like this. So we're going to add it in this way. We're going to add it in vice versa. So I'm going to add c here behind at a time, right? So it's going to start, c is going to start as h, right? So c currently has h. So you can picture that this is h. So this plus this is just h, right? Because remember, this is an empty string. Then c becomes so basically now the string is has h, has the value h, right? Remember this string that I'm talking about here is the reversed string, the one that I called reversed. That's the one I'm talking about here. So now that reversed string has h, but then c now has e. So, and I'm adding it before h, right? You see behind. So that means this will be e, h. And then c now has the value l, and I'm adding the l behind e. So this will be L, E, H, and then so forth, and then so forth until you have the reverse string, which is hello, like this. So that's the formula. It's as simple as that. So how do you write it? You're going to say reversed, right? And then is equals to reversed, right? And then here you're going to say, this is C, that's small, that letter C. You see, I'm adding it behind. If you do it in the other way like this, right? It gives you back the same string. So I want to reverse it. So I don't want to get the same string. So this will be C plus that, right? This is going to reverse the string. But then they said you should capitalize this letter before adding it. Remember, it should be reversed and capitalized. They said in all caps. All caps means in capital letters. So remember that function to upper. Yeah, now our code is going to look very complicated. So you need to say to upper. But then remember, this whole thing returns an integer, so we need to cast it. So I'm going to cut it and say static underscore cast to a char, then pass that whole function in there. So this will make it an uppercase letter before reversing it, before adding it there. And then done, we have our reversed string. Then now I can output the reverse string. So I need, remember they should output put labels for your outputs, right? So I'm going to say reversed and capitalized string, and then I output the string. So reversed, and then I'm going to output end of line character, two of them. So end of line, end of line. Then build and run. And then let's do it right. Enter the string. Vortex Academy is the best. And then boom, magic. Vortex Academy is the best in reverse and capitalized. Yeah, it's cool, right? Coding is fun, man. It's not really nice if you don't understand what you're doing, but it's kind of fun when you know what you're doing. But then we haven't handled for X, right? But then it's fine. You can actually, I think it actually works. Let me press X. Yeah, it closes. It works. You don't have to actually do anything for X because remember when you enter X, it's gonna go here, case X. There's nothing under X, then it's gonna just skip and go here, and it's gonna check, did you enter X? In this case, yes, you did. So stops. The loop stops. So you can actually here, you can literally like do nothing here. You can literally do nothing here and leave it as it is. That's fine. And then your code is done. Then it's gonna run. Hey, this code is a lot. Hey, look at how many lines of code here. Do you see here? 227. Hmm. Look at how long this thing is. Just to output a small program that enters options. Uh, coding is something else. I advise you guys to go and practice this thing. Let me fix it here. Let me say validate index. You see, copying and pasting. Validate index. And then here, get index. But it's fine. Let me put the comments. Get the index. Then here, get the common difference. And then here's that number. Get the start number. Then yeah, I think that's fine. So that's the solution. This is the practical. This is what you guys are supposed to do. All these lines, they're supposed to come from you. Everything that's here is supposed to come from you, from your brain, and you doing your research. So this will be it for today's tutorial. I'll send the practical in the group. So let me stop recording, then I'll take questions now if anyone has a question. Do you have any questions?